Welcome! Today we'll be exploring Ionic Radius. My name's Brian, and with me today are the lovely Hannah and Jillian. So let's get started. In order to understand what Ionic Radius is, we have to first understand what atomic radius is. Atomic radius is the radius of a neutral atom. That's atom. So, alright, whenever an atom either gains or loses an electron, it turns into an ion. The ionic radius is merely the radius of an atom's ion. And we'll get into the trends, but as you can see, by group, they add on layers of electrons and they get larger. These are the transition metals, and therefore they have lower energy. I thought this was just a swell graph that explains the concept. Basically, a cation, I usually think of positive cats. Meow. But positive cats the atom is larger than the ion. But if we look at the anions, they are the negative ones. The ion is larger than the atom. And so it's a little different, but we'll explain it a little bit better when the time comes. So how is ionic radius measured? I mean, do we use a ruler? Of course not. It is usually measured in nanometers or picometers. The radii vary based on their environment, but they follow a general trend. What trend, may you ask? Well, these trends. In groups, as you move down a group, layers of electrons are added, which naturally causes the radii to increase. While in periods, as you move across a period, the atomic radius goes down for the cations. Do you remember what charge the cations are? That's right, positive. It increases for the nonmetals, though, or the anions. They are the negative ones. So following those trends, you can see as you move down, the ionic radius increases. If you move across, it decreases, but then comes back up, and then decreases again. Therefore, fluorine would have the smallest, and francium, I believe, have the largest. Now you may be asking, Brian, what about these ones? And my answer to that is, noble gases don't form charges, or ions, so therefore we can't really include them in this measurement. So now it's your turn. Let's give it a try. Try this practice problem. Which element has a larger ionic radius? Lithium or beryllium? Good job! The correct answer is lithium. Because if you follow the periodic trend for the cations, which are, that's right, the positive ones, lithium has the larger ionic radius. Good job. So proud of you. Alright, which element has a larger ionic radius? Nitrogen or oxygen? Good job. The right answer is nitrogen. Why, you may ask? Well, following the same rule as the first problem, nitrogen is before oxygen and it decreases across a period. So now we're going to talk about electron configuration. When you lose an electron from the cation, you remember what charge those are? I know you're probably sick of me saying this, but remember, they're the positive ones. Think positive cats. You lose an energy level. If you gain an electron, you fill an energy level. Effective nuclear charge. The loss of electrons increases as the ENC, or effective nuclear charge, of the electrons remaining on the ion. Adding one or more electrons to the neutral atom to form an anion, or negative, decreases the ENC. Basically, the effective nuclear charge is inverse of the ionic radius. You may be asking, Brian, what the heck does that mean? All that means is for when ionic radius increases, effective nuclear charge decreases. For when ionic radius decreases, effective nuclear charge increases. So now I'm going to leave you with a very fun problem, if you ask me. Which element has a smaller ionic radius? Not larger, smaller. Sodium, that's this one. Or potassium, that's that one.